The technologies running billion-dollar enterprises are often the absolute least exciting technologies you can possibly imagine. Think about it. When you picture a massive, incredibly profitable global enterprise, you probably imagine their engineering teams have unlimited budgets to just play around with the bleeding edge of innovation, right? But the reality, the systems actually powering the global economy run on tools that most developers would consider, well, incredibly boring. Welcome to this explainer, where we're going to break down exactly why that is.
It's a totally fair question. So if these giant enterprises have unlimited budgets, and I mean unlimited resources, why aren't they always adopting the latest, sexiest tech stacks? In the software world, we have this deeply ingrained assumption that newer always equals better. But what if that assumption is actually a massive liability for mature business? What exactly do these giants know that your average scrappy startup doesn't?
Well, to figure that out, we've got to look at the core philosophy driving mature engineering organizations. Engineer Dan McKinley really hit the nail on the head in his famous essay, Choose Boring Technology. He wrote, "If the problem you are solving is not unique, your solution should probably not be either." Enterprises don't succeed by maximizing their technical sophistication. They win by picking predictable, widely supported technologies. Think standard Linux distros or the mature Microsoft ecosystem. They are ruthlessly optimizing for reliability, predictability, and talent availability rather than just pure innovation.
Okay, let's dive into part one, the exciting technology trap, or as I like to call it, remembering that you are not Google.
It happens all the time. Startups look at the hyperscalers out there and think they need to emulate their massive architectures just to be taken seriously. Let's compare microservices and monolithic architectures based on recent empirical research. The tech hype cycle absolutely loves microservices. And sure, they offer high scalability and let independent teams move fast, but they come with immense operational complexity and demand highly specialized skills. On the flip side, you have the humble monolith. People love to dismiss it as legacy, but it actually offers the lowest starting cost and makes data tracking a breeze because, well, everything is right there in one place.
The crucial takeaway here is that premature scaling is really just another form of premature optimization. If you jump into advanced architectures like microservices before you actually have a massive Google-level scaling problem, you are literally just trading simple, understandable problems for incredibly complex, distributed ones. You end up forcing your team to invest heavily in complex container orchestration and tracking tools just to keep the lights on.
Which brings us to part two, the true cost of complexity. Because trust me, this stuff compounds non-linearly over time.
In the enterprise world, complexity is not a badge of honor. It is a massive liability. We can break down the hidden taxes of all this exciting technology into 4 distinct buckets. First, you have cognitive load. This is the sheer mental effort required just to understand the system. Remember, training costs are huge, and code is read way more often than it's written. Second is operational load, the day-to-day effort to deploy and maintain the thing. Third, failure surface area, which is basically the number of ways your system can break. And finally, dependency risk, which is the fragility you introduce the second you rely on external libraries or vendors. Every clever little abstraction you add amplifies all of these burdens.
So how do enterprise architects fight back against this? They adopt a really disciplined framework called earned complexity. This is a total game changer. It completely reframes how we view technical ambition. In this model, complexity isn't a given. It's treated as an incredibly scarce, expensive resource. It has to be earned by demonstrating a measurable, current pain point. And it has to be paid for by actively funding the operational controls needed to manage it safely.
So how does a team actually go about earning that complexity? Well, they have to pass through some strict gates. Gate 1, evidence of pain. You can't just say, hey, we might need this later. You need real, measurable constraints like actual production incidents or massive delivery bottlenecks. Gate 2, alternatives analysis. Basically, have you tried simpler procedural fixes first? You only escalate to architectural complexity when local optimizations totally fail. And finally, Gate 3, rigorous cost-benefit modeling.
Let's actually look at how teams mathematically model these decisions. They literally score proposed tech on a scale of 0 to 5 across dimensions like load, risk, and reliability. For an exciting new technology to get the green light, the calculated benefits, things like delivery velocity or performance efficiency, must outscore the cognitive and operational costs by at least 4 points. If it doesn't clear that threshold, the tech gets rejected. It's a pretty brilliant way to enforce architectural restraint.
Moving on to part 3, why boring technology wins. Because out here, battle-tested beats bleeding edge every time.
If complex technology is so heavily gated, what actually makes it through? The answer is boring technology. To understand why, you just have to look at the Lindy effect. This is the idea that for non-perishable things, like ideas or tech, the longer it has survived, the longer its remaining life expectancy. Every single year a technology survives without going extinct, it proves its robustness. This is exactly why ancient languages like C or even COBOL from way back in 1959 still undergird so much of our critical global infrastructure today.
Old software survives for a few really powerful reasons. It's got proven patterns, massive communities, and it gets deeply, deeply ingrained into layered infrastructures. It's usually highly optimized for very specific tasks, but honestly, the biggest reason? Old software has had years and years of edge case bugs and chaotic production failures completely ironed out. Ripping it out to replace it with something shiny and new introduces massive, totally unpredictable risk.
Get this staggering statistic. Over 80% of fintech APIs run on the Spring framework for Java. Over 80%. Now, in 2026, Java is definitely not considered a sexy language by startup standards. Yet, it is out there practically printing money for banks, payment processors, and massive risk platforms. They choose it because it delivers unmatched stability, memory safety, and crucially, a massive, reliable hiring pool.
But here's the thing you have to remember. Boring technology absolutely does not mean stagnant technology. With recent updates like Java 21 introducing virtual threads, Java can now handle millions of concurrent operations seamlessly. Plus, because Java is so strictly structured and predictable, it provides the absolute perfect deterministic safety net for AI-augmented development. When AI is writing up to 70% of your code, enterprises desperately want a rigid, boring language to keep those AI hallucinations safely in check.
All right, part 4, the cloud and AI reality. Let's look at how this applies to modern infrastructure.
We are seeing these exact same lessons apply to infrastructure. Take Kubernetes. For years, it was the unquestioned absolute standard for cloud-native deployment. But now, enterprises are waking up. As InfoWorld noted, Kubernetes can feel like over-engineering disguised as strategic modernization. It demands massive operational expertise, constant tuning, and incredibly strict governance. It literally became a heavy tax on operations teams, which is why a lot of organizations are perfectly happy sticking to good old reliable virtual machines or proven VMware environments. Because of that operational tax, enterprises are increasingly backing away from raw Kubernetes. They're pivoting toward curated internal developer portals and managed platforms. The goal is to abstract away all that orchestrational cognitive load. Developers don't want to be part-time cluster operators, right? They just want to deploy their apps quickly and safely. Enterprises are actively choosing simplicity and developer productivity over owning and managing every complex layer of their infrastructure.
And we are seeing the exact same parallel right now with AI. Despite all the intense hype, enterprises aren't blindly rushing to deploy every bleeding-edge AI model into production. They're applying those same earned complexity principles we talked about. They are heavily prioritizing strict governance, security, compliance, and cost control. They're carefully weighing the risks and making absolutely sure the business benefits significantly outweigh the heavy operational burdens.
Which brings us to our final section, Part 5, Battle-Tested over Bleeding Edge.
Bringing this all together, we get a massive paradigm shift. The best technology isn't the newest technology. It's the technology that reliably solves business problems. True engineering maturity isn't about showing off how many ultra-complex microservices or bleeding-edge frameworks you can string together. True maturity actually manifests as restraint. It's the sheer discipline to keep things as simple as possible for as long as possible. In fact, empirical studies back this up, confirming that starting with a monolithic architecture is literally the fastest and cheapest way to launch a minimum viable product. You really should only switch to a more complex architecture when the monolith actively starts making growth impossible. Simplicity first isn't just a philosophy, it is backed by hard data.
So the next time you look at a billion-dollar enterprise and kind of sneer at their boring Java monoliths or their traditional relational databases, you really need to ask yourself a different question. Is this stack actually outdated, or has it simply survived years of production fires and proven its immense economic value over and over again? These legacy stacks are, for sure, the unsung heroes of the global economy.
If this explainer changed how you view enterprise architecture, please hit that like button, subscribe for more insights like this, and share this with your engineering team. Now I'd love to hear from you down in the comments. What technology do you use every single day that is incredibly boring but absolutely essential to your business? Let us know.